Hello guys, in this video I am going to demonstrate the solution of question number 12 of chapter 13 from the book Engineering Circuit Analysis by Hayt, Kemmerly and Delby. So the question says that for this particular circuit, first of all we need to convert it into the phasor representation. And then we need to write a complete set of mesh equations. We have 3 mesh, right? And then we need to calculate I2. And it is given that B1T is this. Now when we say the first part, the phasor representation, with the phasor representation we means that the circuit in time domain need to be converted into the frequency form. Means we need to convert all these terms into the impedances. And this, if like V1 it is 8 sine 720t, so it will be converted into 8 angle 0, right? So over here, like if I redraw this circuit, so it will be something like this. Over here we have plus minus V1, so this V1 it will be 8 angle 0, or let me put it over here. V1 is equals to 8 angle 0, right? Over here it is 1.8 ohms. Then this, then we have this. Now this is 1 millihenry, and from here you can see that our, like if you compare it with the general equation, we write it as sine omega t. So it means that our omega it is 720 radian per second. Radian per second. Let me write it clearly. Radian per second. Right? Now over here the impedance is 1 millihenry. So we know the formula that if L is there, if L is this, for L the impedance will be j omega I. So since omega is 720, so it is 720 into 1 milli, so it is 10 power minus 3 j minus 3, right? So it means it is 0.72 j ohms. So we put it as 0.72 j. Now similarly we have the capacitor, and this capacitor it is 1 millifarad, and we know formula is 1 upon j omega c, right? So it is minus j upon 720 into 10 power minus 3, so it is minus j upon 0.72, minus j upon 0.72, and if this will give you the answer as minus 1.39 j. So this will be minus 1.39 j. After this we have one inductor, and this inductor is 2. Now again we know this, so over here L is 2 milli, so it will be 2 cross, so it will be overall it will be 2, so it will be 1.44 j omega. So it is 1.44 j, right? And the next is this, so we will put this 2 ohms, so all are ohms, right? And there are 3 loop currents. One is I1, I2, I3. So this is the first part of the question, where it is asked that we need to draw the circuit in phasor representation. So this is phasor representation. Now the second part of the question says that we need to write a complete set of mesh equations. So when we apply, okay, one more thing, dots. Over here the mutual coupling dots. So one dot is over here, another is over here, right? And also this M. Now this is 500 nanohenry. So again like similar to L we have this M. So similar to M we have this J omega M. M is 500 into 10 power minus 9, right? So substituting it over here, we get J 720 into 500 into 10 power minus 9. So this is going to be 36.36 into 10 power minus 3J omega. So this is our mutual coupling, this. So this also we will put it over here. So this mutual, it is 0.36 into 10 power minus 3 G omega. So now it is the complete circuit in phasor form, right? In phasor form. Now this now we need to write a mesh equations. Now while writing a mesh equation, the first loop is, so writing KVL for first loop. Now for the first loop, so we will start from this point. So it is minus V1, second plus minus, so it is plus 1.8 I1, and then we come to this inductor. Let the voltage over here, let it be VL1 plus VL1 equal to 0. Now what is this VL1? Now over here we have the self inductance as well as the mutual inductance, and over here for the self inductance, with respect to the self inductance, since I1 current, it is flowing in this direction, in the downward direction. So with respect to the I1, the voltage that will be induced in this inductor due to self inductance, it will be L di by dt, or simply 0.72 J I1, right? And since the current is flowing from top to bottom, so like this, so plus will be at the top, minus at the bottom, and it is aligned with the polarity of VL1, so we will take it as positive. Now coming to the second part, the mutual inductance. Now over here for the mutual inductance, we know that to this polarity, this dot, it will be positive. This will be positive if the current is entering, entering through this node. If the current is entering through this dot, then it means this dot will be positive, right? But to align the polarity with VL1, what we need? We need negative at this dot. To have a negative at this dot, we instead of current entering, we want current should leave the dot. To leave the to make the current leaving the dot, what we want that I3 should be big and I2 should be less. So the current should be I3 minus I2 to flow it from down to bottom to top, right? So that the current is in this direction, and if the current is in this direction, then it means that the current is leaving this dot, right? And if the current is leaving this dot, then this dot, it will be negative, and if it is negative, then this VL1 over here, it will be positive, so the polarity will align with that. So it means the current is I3 minus I2, so, and the mutual inductance is this, so it will be 0.36 into 10 power minus 3 J I3 minus I2 equal to 0. So this is our first equation, right? This is our first equation, right? and this can also be like we can or let it be the first equation. Now coming to the second part. Now the second is that we need to write the equation for this loop, second loop. Now writing the equation for the second loop, over here again we have two inductors, so let it be VL1 and let this be VL2, right? So let me erase little bit. Yes. So if this is VL1, if this is VL2, so our equation, or let me give the polarity as plus at the bottom, minus at the top, so that because I2 is flowing in this direction, right? Similarly like for this I2, since I2 is flowing in the downward direction, so we give plus at the top and minus at the bottom, right? So applying the KVL for the second loop, it will be our VL1 plus I2, this is I2, right? So it will be plus over here, minus over here, so minus 1.39 J I2 plus VL2 plus this VL2, this one. Now what will be VL1? Now VL1, it is the voltage due to self inductance as well as the mutual inductance. So if I want to calculate the VL1, so VL1, it will be first, it will be because of the self inductance. Now I2 current, it is like one current I2 is flowing from bottom to top, and I1 is flowing from top to bottom. So to make, like if the current is I2 minus I1, then the current, overall current, will flow at the top from bottom to top to keep the polarity, this polarity as positive, right? So current will be I2 minus I1 into impedance, which is 0.72J. Now coming to the mutual inductance. Now to have positive terminal at this dot, the current through this dot should enter. If the current enter through this dot, this second dot, then only the polarity at this dot, it will be positive. So the current will enter through this if the current is I2 minus I3. So the current I2 minus I3 is entering through this dot, so that at this terminal, the positive, this terminal will be positive due to mutual inductance. So it means that our mutual inductance, it will be I2 minus I3, and mutual inductance is this 0.36, or simple 0.003 0.00036J, right? So coming, once we get VL1, now similarly we can get VL2. Now for the VL2, now the positive terminal, let me erase little bit. Yes, okay. So to have positive terminal over here due to self inductance, the current should flow from top to bottom. So it means that the self inductance, it will be I2 minus I1 I3 into impedance is 1.44J, right? Then then the mutual inductance over here. Now the mutual inductance will be due to this inductor 0.72J. Now over here, to have positive terminal at this node, the current should enter through this node, through this dot, right? So it means that the I2 over here, there are two current, I2 and I1. So this current should be I2 minus I1. So that if current I2 minus I1 is entering through this dot, then the positive terminal will be induced over here. So it will be I2 minus I1 into mutual inductance, which is 0.00036 J, right? Now substituting this VL1 and VL2 in the equation, what we will get? We will get now VL1, it is this. So I2 minus I1 0.72 J. Then the next term is this I2 minus I3 into plus I2 minus I3 0.00036 J, right? Then this term minus 1.39 J I2, and then for VL2 we have this. So it is I2 minus I3 1.44 J, and then I2 minus I1 into 0.00036 J, right, equals to 0. Now over here, take all the I1 together, I2 together, and I3 together. What we will get? Okay, so the first expression, it is I2 minus I1, right? So over here I need to put it as I2 minus I1. So over here, the first, let me take I1. So it is minus I1. So I1 coefficient minus 0.72 J. Then I1 is over here. So it is this 0.00036. So minus 0.00036 J. Now I2 plus I2. So I2 first is this. So it is 0.72 J. Then this, it is plus 0.00036 J. Then this plus minus 1.39 J, and then this, it is plus 1.44 J, and then this plus 0.00036 J. So this is I2, right? Now I3. So first minus 0.00036 J, right? Then this one, it is minus 1.44 J equals to 0, right? Now solving this, we will get minus 0.72036 I1 J I1 plus this. So this will be 0.72 1.39 1.39 plus 1.44, so 0.05, so 0.05, okay, just a minute, 5, 15. It is 1.44 minus 1.39, it is 0.05, 0.05 added to this, so it will be 0.77, 0.77, right, plus this and this, so plus 0.00072 G. So, or simply we can add this, so 0.0072, so it will be 0.72 J I2, and then so it is simply this complete thing, it is 0.77, okay, and the third one it is this, so it is minus plus I3 or minus 1.44036 J equal I3 equals to 0, right. So this is our second equation. Let me check it once again, right. So over here we have put this VL1, like looking at a circuit, we get this, like we get, just a minute, okay. Yes, let me bring up into it. Okay, so over here VL1 plus minus 1.39 J, and then VL2, right. So this is okay. Now VL1, so VL1 it is like positive over here, so to get a positive we get I2 minus I1, it is correct, 0.72 J. Then the mutual inductance, then the mutual inductance, just 0.72, yes, and then I2 minus I3, yes, it is correct. Then this, then 1.4 J, this, so it is correct, right. Okay, and then substituting these values over here, we have this expression, it is okay. Then I2 minus I3, this is okay, this is okay, this is okay, and this is okay, right. So we get this term, it is okay. Then this one, it is 0.72, right. Then A 0.036, okay. Then minus 1.39 plus 1.44 and A, right, it is okay. So we get this again 0.72, 1.39 and 144, so 0.05, so we get this, right. Yes, so we get this equation, so it is correct. So this is our second equation, and now for the third equation we need to apply the loop for this. So over here the equation, it will be V, like again changing the polarity, like over here we take plus over here and minus over here, right. So it will be VL2 plus 2I3 equals to 0. Now VL2 will be equals to 1 due to the self inductance. So if we follow this current, then it will be plus will remain over here. So the current over here, it will be I3 minus I2. So I3 minus I2 into 1.44 J, and then the mutual inductance to have to just a minute to keep positive over here. To keep positive over here means to keep negative on the dot side. The current should leave this node. The current will leave this node if the current is I1 minus I2. So I1 minus I2 into mutual inductance, which is 0.00036 J. Now having this VL2, we will use this equation. So we will have I3 minus I2 1.44 J plus I1 minus I2 0.00036 plus 2I3 equal to 0. So over here just rearranging, so we have I1, so it is 0.00036 I1 J, I1 it is J. Then I2 is this and this, so it is my plus I2, so it is minus 1.44 J minus 0.00036 J. And then I3 is this and this, so it is 2 minus plus 1.44 J I3, right? So over here, solving this, we get 0.00036 J I1 plus minus 1.4436 J I2 plus 3.44. So it is next, so it will remain as it is I3. So this is our third equation, right? So this is the solution to the second part of the question, which says that we need to write the complete set of mesh equations. So these are the three equations, right? These are the first one. Let me show you the complete one. Yes, so this is the first one. Okay, not 0, only 1. This, so this is the first one. This is this second equation, this one, and we have the third equation over here. This is the third equation, right? Now over here, the last part